Hello, everyone. It's 30 minutes past by my clock, so go ahead and get started here. Hopefully everyone can hear me. Today we're doing team training for the GitLab operator. This is a bit of a technical deep dive where I'll jump into introducing the operator, but kind of jumping more into how to get started with the project for distribution team members that want to get in and need to work on an issue. So we're doing the intro, a little bit on, like I said, getting into developing on the project, and then a little bit more of a behavioral deep dive. So depending on what your experience is already with the operator, different portions of this might be applicable. So the intro kind of applicable. Why people who have already had a deep dive being more applicable to people who want to take a closer look in, but also people who have just started developing and looking at the tests and stuff like that in the operator. So let's go ahead and get started with a quick intro. So the operator that we've developed is basically the purpose for it in our GitLab chart is to watch for GitLab version changes that we've done a Helm update, and to basically run through the appropriate steps for migrating the database and restarting the pods in rollout order, similar to what we do for GitLab.com. That should result in no downtime. So this is currently something that we weren't able to separately do with Helm to actually control this rollout in a way where we could do the pre-migrations and then roll all of our pods and do the post-migrations. As we'll get into it and show, just the concept of just rolling, or rather a rolling restart rather than a rolling update, isn't really something that is in Kubernetes. And so we had to instead use more of treat a restart more like a bit of an upgrade, even when there aren't changes. So this is something that we've included in the GitLab chart where we've bundled the operator into it. It's experimental, and we're keeping it experimental until we're confident in its stability. And basically, the operator is Kubernetes controller, specifically targeting a custom resource controller written in Go, and we currently use the Cube Builder library and framework to do that. So I've linked the projects below on this slide. So for a high-level overview of what it's doing, still from a bit of a technical side, or rather how this thing gets it, how this thing is deployed and used in our chart. Basically, the Helm chart provides the cluster when it's installing the necessary settings to create a new custom resource, a new GitLab custom resource. And that's using custom resource definition. So the Helm chart installs the custom resource definition and also sets up some role-based access control settings in order for our controller to respond to those, to deal with the custom resource. Then that same Helm chart deploys basically just a deployment of an operator pod, our operator pod, and that pod watches for events to the GitLab Kubernetes resource type. And I've linked to the operator subchart in our Helm chart for that. And then the Helm chart again creates an instance of the GitLab resource. So the first thing it did was just create the schema definition, the custom resource definition. Later on, it creates the actual instance of the resource. It embeds the current GitLab version in that resource and other setting information. And then the chart goes on to create other various resources for the GitLab application that we've all seen it doing before. Meanwhile, the operator that we've deployed with the chart starts responding to the creation or update of that GitLab instance object and it starts interacting with the other application resources that we have, creating some new ones, interacting with some existing ones in order to roll out upgrades smoothly, basically without, or trying to minimize downtime. It takes care of handling the migrations, for example. So also as part of the intro, just to run over to go over the rollout behavior for sort of what we're actually doing when we're saying we're rolling out a new version of GitLab. During this, what's called a reconcile run, or during this response to the update of the GitLab object, the operator takes the following rollout steps for these new versions. It pauses any existing deployments that are happening in the chart, GitLab related deployments. It runs the GitLab migration job, so it creates a new Kubernetes job to run migrations. And that first job it creates for migrations does not include our post-deployment migrations. So these are the non-post deployment migrations can run still while the GitLab is up without causing downtime. This is similar to what we do in Omnibus for GitLab.com. We then restart the Gitly pods specifically to ensure that they're restarted before the rest of the pods. We then unpause all the other deployments that we paused earlier. And because this is done during an upgrade, we expect the pods for something like Unicorn to end up rolling out the new versions of the GitLab image. Finally, well, almost finally, after those versions have been rolled out, we then run the post-migration jobs, which are now running, and the GitLab code has now been updated to be able to use the results of those. But finally, we have to perform, after those migrations run, we have to perform a final restart of the GitLab pods in order for those pods to kind of refresh their cache of the database schema to fully make use of those new whatever happened to the schema in those post migrations. So that's kind of the rollout behavior. That's the behavior the operator takes. That's what we wrote it for, and that's kind of the behavior that we weren't able to easily see how to do with Helm alone or with our other templating. So to just so that's kind of the end of the introduction. Hopefully that was fairly quick. To just jump into the operator project and working with it. So if you haven't built our operator before or worked with it or done any testing or looked at the code, basically you need at least Golang 1.9 or newer. I think a lot of our other projects are using newer, so you might as well use 1.10 or newer than that even. The Go dependency tool dep needs to be installed, and then also the Kube Builder framework needs to be installed, and its binary is available on your local path, and it's used for both for some of the scaffolding work and updating dependencies in the project, as well as if you want to run the tests locally, the tests by default use the Kubernetes binaries that were shipped in the Kube Builder framework. So all that information on where to go to install the Kube Builder framework should be available in the README on the project. One of the things is, if you're not super familiar with Go projects, the pathing can be a little weird if you were just expecting to go to your normal Git checkout folder and check out this project and then run these commands, and it didn't work. And that's because the Go dependencies are expecting certain pathing. An easy way to get that path set up right is to use the go git command to do the initial checkout of the GitLab operator. So I've included the command there, but it'll basically set up a directory structure that's nested in the way that Go expects. And in a second here, I'll jump into the actual the structure of the code, our file structure, to explain it a little bit more. So it won't all be slides here, but just I think as one of the last slides before we start doing that, I just wanted to go over what some of the components involved in the operator are, and we're kind of the division line between what our code does and what the Cube Builder framework does. So in the README for this project, we had previously included a components list that's a little bit outdated. It references the components before we started using the Cube Builder framework. So as a result, I have a merge request up to update it now. But the updated components is there's a bunch of the old components that are now handled for us as part of the controller runtime package. So the controller runtime package is a Kubernetes package that is kind of a somewhat standard package that backs custom controllers, both for Cube Builder, but also for the kind of competing helper tool for custom controllers is the Operator SDK. But this common controller runtime package kind of backs both of them, and they both just sit with their own conventions on top of it. But that runtime package we now use for several of the components that typically make up a custom operator. So that's includes the manager. So the manager is literally just the like startup command, basically, that the Docker image actually runs. The controllers themselves are registered with the manager to kind of add them. Like the manager finds all the controllers it's responsible for and starts them up, basically. And then the manager is responsible for like crash loop backups and stuff like that, like things you would typically want to get into a process in a container type thing. So the manager takes care of more of the containerization of things and starting the process. So that's actually handled for us by the controller runtime. We're not doing anything custom there. The client and client sets, so what those are they're kind of the Go versions of the kubectl git and put and a lot of other stuff. So basically the code required to do CRUD operations in Kubernetes, but then also because we're adding our own custom resources here, there's a bit of CRUD operations that have to be specific to our GitLab resource. And the controller runtime also auto-generates the client specifically for that. Things like listers are auto-generated using controller runtime. So the listing components for listing the GitLab objects are generated, and sourcers and informer. So in Kubernetes, the informer is what's providing the event to the operator. So like what has changed, what are we responding to? In the controller runtime, they wrap that in something called a source. In our case, we use what's called a kind source. So in Kubernetes objects, you have like that kind field that says what it is. So a kind source just means that you're dealing with a Kubernetes object, and the kind source receives or sends events based on that an object in Kubernetes changed. There's another source that we don't use that is used for like external components. So these controllers could also respond to things outside of Kubernetes on webhooks or something like that. But basically all of that code has been turned into kind of common boilerplate code and moved into the controller runtime. So our actual package now just contains basically the custom resource, the GitLab custom resource type. So the schema definition for that, the GitLab custom resource definition, which is actually auto-generated from that type, but it does reside in checked into the code base, and then the controller itself are all that are really our code inside of the operator. I've linked out to the controller runtime docs at the bottom of this slide if you're interested in. The link I provided actually links out to their listing of the components included inside of the controller runtime. Okay, so now I'll finally get away from these slides and take a look at our actual structure. So if you were wanting to get started with this and you've done the go get, you would end up with structure kind of like this. So I'm going to jump in from kind of the location of what if we had just been running this in the Helm chart and I wanted to see what was running type thing. So if you just jump into the Docker file, we would see that some binary called the manager is what we're actually running when we run the operator image. And basically the source code for that manager can be found, or the manager command can be found in here under the command manager file. And this is, we haven't customized any of this. This is just the auto-generated manager wrapper, which basically wraps the controller runtime manager. And let's see, it gets a kubectl config to communicate with the API server. Then it registers our new GitLab object. This API is here is our GitLab object here in the GitLab operator. And then also registers our controller to the manager. And then the manager starts, and the boilerplate or the upstream code takes care of actually doing all the rest of the work there. So based on here, there's two different areas we could jump into. There's the API or the GitLab object itself, and there's the controller. So both of those are under the package folder. So under APIs and controller, under APIs, under GitLab and its version. But basically the types file, the GitLab types file, this is what actually defines what our GitLab resource is. So the top level object is a GitLab resource. It has some Kubernetes metadata. It has a GitLab status object. It has a GitLab spec object. The spec object we can see up here. We have a version. We have a list of templates. And we have the Helm release version as well. So that's basically what we're including in our GitLab object. The other, so that's the kind of type, and then the API object that gets auto-generated, or it doesn't get auto-generated. This file is used to auto-generate all the code necessary to do like serialization. So that's why this is called, you'll see this called a schema, basically. So this file and these JSON fields define how our Go GitLab object can be translated between a Go object, a serialized object over gRPC, or a JSON object through, of course, all the YAML files for kubectl gets turned to JSON first. So this file basically defines those transitions. And the rest of the code in this API is basically boilerplate type code. The other interesting piece is under controllers, like I mentioned before, the GitLab controller. And that basically has an add function where it actually gets added to the manager, and a reconcile function, which does the meat of the work, which we'll jump into later. So that was kind of the folder, the structure, the layout. To jump into more of a behavioral deep dive, I'm going to go back to the schema object a little bit. So it was the GitLab type file. So like I mentioned before, we're storing the version, a couple templates, and the Helm release version as well. Additionally, that templates list basically includes the migration template, which is the template actually, our templates actually just contain a config map key and name, and we actually store the templates in a config map, and this GitLab object just has a reference to the config maps. And we have one for the shared secrets creation. So the shared secrets are what create a lot of our well, secrets, but things like the auto-generated Postgres password and stuff like that. If you haven't provided your own, it does all that sort of generation. But basically, this file ends up generating a CRD, which we can see under the config CRDs. So it kind of auto-generated this file, which is what we actually we copied this file into the GitLab Helm chart. So if I jump over to the Helm chart, and just a second, I'm going to reveal and preview here. That CRD also ended up here. So it's auto-generated in the operator, and then we copy it over when it's been changed into the GitLab chart, because it gets added here. Okay. And then in the GitLab Helm chart, we can also see the GitLab file, which is actually the instance of the custom resource. And we can see this is where we're defining the version, the Helm release, and those templates that we saw before. So this is what ends up being the YAML representation of that object that we saw over in the controller, in the operator. One kind of interesting note where we've deviated a bit or added some functionality is our type actually has subgrouping. So let's see. So by default, you have like this named resource for what your custom resource definition is. By default, we have it set as this, but it can also be set slightly differently with a subgroup. We do that for isolation. If I jump in back to the Helm chart, we jump back to the CRD. We can see in the Helm chart, we actually, you can't see it very well here, but we actually include a group name here. So instead of just being the default GitLab.com, we include the Helm release name in this in order to provide isolation, so you could install multiple GitLab charts and they each install their own CRD. That's currently handled in the register function here, which is adjacent to the GitLab types. Basically, we have this subgroup that the operator knows about. So by default, it's just looking for, the GitLab.com CRDs. But if the operator's been given a subgroup, it further filters it down to something more specific. So that's one addition we've made that isn't part of the default scaffolding. Usually you would just have had your base group here. Then one of the other things I should show regarding the object itself is how we pass along those template files. So for example, the two templates we were passing along were the shared secrets and the migrations. So these were things that without the operator we've had in the Helm chart for a while, so we had to make some changes in order, if we wanted to use them in the operator, we have to change our behavior based on whether we're using the operator or not. So when we're using the operator, the migration job basically gets created as a config map rather than an actual job running that Helm creates. So Helm's no longer creating the actual migration job. Helm's just creating a config map that contains the information that it would have used to create it. And it passes that to the operator, and the operator becomes responsible for creating it. So if we jump into the migrations job, we can see that this job YAML here used to be what Helm did to create the job. And currently it's kind of been stubbed out, that it only runs if the operator is not enabled, and in which case it includes this job spec field, which is the job spec field is the job definition that we had before. And then optionally in our config maps, we now have this migration job spec config map that gets stored. So that's kind of a weirdness there. We do that in order to kind of maintain this balance between being able to use the Helm chart to install everything, and then optionally use the operator. That's how we're currently doing things. So to jump out of the GitLab type specifically, and to jump specifically into the controller, kind of the two main parts of the controller are the controller's add function, which sets up the watch, and then the reconcile function, which does all these things, but I'll quickly jump through them just so people kind of get a little bit more familiarity with it. So this is the operator. So our controller, so the first thing we have is this add function. So this is what's being called by the manager to actually add the controller into the manager list. And it actually creates this controller object is the upstream runtime object, creates a new named controller and attaches our reconciler below. But basically we set up a predicate here that determines based on what conditions do we respond to the GitLab object. In our case, we make sure that we check the version label under this label on the object to make sure that this version of the operator is actually supposed to be operating on this GitLab object. So if I jump back to here, like that's being set here, basically. It's a label on the GitLab object. This is the chart. I realize jumping back and forth might be confusing. I should really say what I'm jumping back and forth between. But basically, that just means that unless this version label doesn't match, if it doesn't match the version we have in the operator, the predicate is supposed to mean that this instance of the operator won't respond to it, that it was meant for a different operator, a different version of the operator. So there's functions for update, create, so just the CRUD operations, and then a generic catch-all for other things. We're only really using these two at the moment, the create and the update. We've populated the delete, but it's we're not really responding to it. And then the controller sets up a watch using that predicate. It passes in this predicate function into the watch, but it basically, this is where we're talking about the source type before. It's basically looking at the GitLab object. And we'll be basically enqueuing any, events for the object. So it'll watch for any changes to the GitLab object, which we change on every Helm install update. There's a Helm revision in the object as well. So if I jump back to the chart where we're defining it, we actually have the Helm release revision included in the label as well. So every time you do a Helm update, that at least changes, which will basically trigger the event, or it'll enqueue update operation. And this controller will be watching for that and calling the reconcile function. So the reconcile function, you'll sometimes call it a reconcile loop. In the case of KubeBuilder, it's only a loop in that if you don't complete the event, like if you don't fully get to the end of the reconcile loop and instead you just are returning the event back because you hit some failure or stuff like that, it'll continue to respond to that event. It'll kind of try again type thing. So in that regards, it's a loop, but it's not actually just always running. In this specific case, it's basically just running off of that queue of events, and it doesn't fully take off. It doesn't remove the event from the queue until it's reached the conclusion of its reconcile run, basically. So you hear it called reconcile loop. In other controllers that aren't using Cube Builder, the function is often called the sync or the sync handler rather. So if you end up looking at other controllers that aren't based on Cube Builder and you see something called the sync handler, that's often doing the same thing. And basically, it's receiving our updated GitLab object, and we're supposed to make changes to the cluster based on that object. So to actually walk through what we're doing in Reconcile, it's basically those steps that we talked about before for rollout. It's actually getting the GitLab object, but it pauses the workloads or pauses the other deployments. This is one thing we didn't talk about in the Komodo before, but it currently attempts to get the current version of GitLab and check to see if we even need to update. Now, I have an issue log to remove this. We're not actually using this bit of code right now in the operator. The reason being is we never annotated our deployments with the version that is checking, so it's never getting a version when it's checking, and as a result, the update required is always basically failing out, and we're always saying, "Oh, I'll just update anyways." The reason is the way it was currently getting the version. It was just using the GitLab release name, and even if you're the same release, if not all of your migrations have run, we would still want this reconcile loop to run. So that's the reason. The current version really isn't applicable. What we'd rather want to have is like, what's the current migration status or something like that to know whether we need to continue to migrate and roll out pods and stuff like that. So currently this isn't being run because it wasn't, or it's not being used because it wasn't accurate enough in enough situations. So instead we're just always running, which is too much, because even if you change something that doesn't need that full rollout, we're doing a full rollout. But at least it's currently working in the situations we need it to as well. So we're currently always running it on a update. We go ahead and we run the shared secrets jobs. We run the migration job, the pre-migration specifically. We do that rolling update of Gitly we mentioned before. We unpause the workload. So we're expecting if we got an update here that there might have been a change to Unicorn or Sidekick or something like that we had previously paused the rollout of that new change. So now we're unpausing here. So those rollouts should now take place. And then it says finish GitLab deployment, but this is really just a wait for those objects to be rolled out before we proceed further. So we're waiting for that rollout to happen. Then we run the post migrations, and then we do a rolling update of GitLab. So it's called a rolling update because it is an update, but in this case, this last rolling update, we're not really trying to update anything. It's just we're trying to restart pods after the post migrations ran, so they get the new cache of the schema. But Kubernetes doesn't really have an easy concept of doing a rollout to doing a rolling restart to the pods. Instead, it only has the idea of a rolling update. So our rolling update, basically, it just changes a timestamp in the deployments, and we're using it as a restart, but it ends up being an update. And then we use the built-in rolling update to handle the rest. So that's the end of the reconcile loop right there. That's all that we do in it. And the rest of this file is basically just those, like the deeper dive into those functions. So I'm going to scroll down. There's the pause workloads. So you can see it's pausing quite a few things. This is probably overreaching. I've opened an issue to review this as well, because things like MinIO and Nginx, and Redis, we probably don't need to be pausing. But currently they're being paused during this. Then the Git current version, like I mentioned, we're not currently using. And the update required we have is currently always erroring out with this, or not with that, but with the could not find, unable to determine current version, basically. This is the rolling update command, which is one of the last ones that happened. And basically, you'll see we're setting a new annotation just to a timestamp. And then we have cleanup jobs. So we create a couple of jobs, including the migration job and the shared secrets. We also clean them up after we're done with them. So there's some code in there for that, cleaning up the migrations, cleaning up the shared secrets. There's a job for actually running the migration. So it'd be a job for running the shared secrets. And then all the various pause commands, because pausing different types of Kubernetes objects are slightly different. And then of course the rolling update of Gitly, which has had its own. And that's actually, so that's everything in the current controller in terms of a walkthrough. Now we have a pretty good amount of time for any questions, or if anyone wants to ask about anything specifically. If someone wants to, if we want to dive into something else that I didn't cover, we have several other experts on this stuff, or at least as expert as anyone on the line. So it's more than just me that can answer some of these questions too. So feel free to ask anything, or if you are confused or want me to re-review something. No questions? Everyone's good?
Yeah, no questions at the moment.
Okay then, if there's no questions, I'm gonna go ahead and end the meeting. It was good seeing everyone, and talk to you later.
Thanks, DJ.